Hello, my name is Stephen Smothers. I'm a citation pilot and a NextGen technology analyst for Cessna Aircraft Company. I work for Engineering Business Development, a department within Aircraft Systems Engineering here in Wichita. Today we're going to talk about the next generation air transportation system. We're going to talk about exactly what is NextGen, what's changing with NextGen, what are some of the technologies that are going to be required for NextGen. But first off, you might be asking, what's engineering business development have to do with NextGen? Well, our department, we have been involved with industry and academic research, and we're also on NextGen committees. We have learned a lot of information about NextGen from the behind-the-scenes interaction we've been having with this work. And that's what we want to share with you today, because NextGen really is transforming the way we're going to operate aircraft in the near future. And we want to share that information with you today. So, why are we going to share this information? Well, our customers are starting to ask about what is the roadmap that Cessna has for NextGen in regards to data communication, FANS, Link 2000, in regards to precise navigation. They're asking questions about RNP and RNAV, and ADS-B. When is our roadmap going to be ready for them to start putting these type of technologies into their aircraft? So what today the overview is about was what we're going to try to do is just give you a general idea of what NextGen is, and also allow you to be able to have that conversation with our customers. Now, what it's not going to do is we're not going to be able to define the precise technical solutions that we're going to have to do for everybody's specific aircraft. Those will have to come later, and we have more information for us to give to you later on in the months and the years ahead. But today the goal is for you to become familiar with what NextGen is. So again, what's NextGen? Well, it's a transformation of the way we operate aircraft and the way the air traffic control system manages aircraft in today's system. It's a paradigm shift really from the way traffic has been controlled in the 20th century using new technologies to collaborative control aircraft in the 21st century. It's a transition from ground-based navigation aids to space-based navigation aids, and also by using data communication to control air traffic. This is going to allow an increase in capacity, and it's going to increase throughput in the high-density airspace and in the metroplexes. This is a benefit for everyone. The FAA has some specific objectives that they would like to do with the NextGen program. First off, they want to safely accommodate increases in system throughput. That'll help out everybody, and especially, as I said, the high-performance airspace. That's airspace above flight level 340 and in the high-density airspaces in the metroplexes. They're also going to use NextGen technologies to reduce the impact that weather has upon that day's operations by allowing visual light separation standards even in poor visibility conditions. This is also going to allow for increases in efficiency, reductions in manpower, and maintenance costs. Overall, NextGen is a dramatic change in the air traffic management system. The old system is going away. So what is exactly changing in NextGen? I mentioned the air traffic control system is transitioning to a collaborative air traffic management. That's also been called CADM. Voice communication, which is primarily used today, and digital communication is secondary, they're going to change roles. Digital communication is going to be the primary way to control aircraft, and voice communication is going to be the backup. I mentioned ground-based navigation, the VORs, the NDBs, the ILSs. Those will be slowly faded away as space-based navigation becomes more prolific in the national airspace system. Passive surveillance or radar technology is giving way to something even better, active dependent surveillance. And the way we get our weather information today is extrapolated, and it's going to give way to something a little bit better, a lot more real-time interactive weather to allow pilots to have more capability to predict exactly what's going to happen to their flight trajectory. Today's operations, you could call them federated or independent. Every aircraft out there is flying on its own business trajectory, but that's going to change to more of an integrated system, or what we also are going to be moving towards called four-dimensional trajectory-based operation, or 4D TBO for short. Let me define that a little bit better. So from the beginning of aircraft pushback all the way to where it shuts down, an aircraft trajectory is going to be defined by its latitude, its longitude, its altitude, and its speed, all in relationship to its time What this enables is more synchronization with other aircraft. That allows an increase in throughput. The system has more capability to absorb more airplanes, and it also really benefits the operator to operate his airplane more efficiently the way they prefer. It's important to note that the FAA is going to give more preference to aircraft with these new technology. They're transitioning from a first come, first served policy to one that's called a best capable, best served policy. Aircraft that do not have this capability of this equipment are going to find that they are going to have delays, and also they're going to receive a disbenefit. They're going to be at a disadvantage and a disruption in their operation. Why is the FAA doing this? Well, they want to accelerate the implementation of these new technologies into the aircraft. So is NextGen real? Well, let's just take a look at what has been happening, some of the activities that are going on. The ground infrastructure, the FAA has been doing a tremendous amount of investment into installing the ADS-B towers all across the continental United States and into the Gulf of Mexico. That effort will be completed in 2013. As you've heard of WAAS, LPV, well, there's 25 to 30 LPV approaches going into airports all across the NAS today. There's approximately 3,000 that have been installed to date at 1,500 airports. They're going to continue that activity. As far as how they control traffic, the old air traffic control computers called HOST, it's outdated, and instead of being refreshed, they're going to replace it with a new modern system called ERAM. ERAM is a next-gen capable air traffic control computer system. Right now it's in 13 centers across the country. There's 20 centers total, and by the end of this year, it's going to have every one of those centers is going to have this technology. So basically, the old system, the old ground navigation systems like the VORs, the ILSs, and the NTVs, once they reach the end of their service life, instead of being refreshed or maintained, they're going to be allowed to go out of commission. And by the end of 2020, there's going to be a skeleton networks of these ground-based systems across the continental United States. Let's just take a look at some of the operational changes that are also taking effect. This chart up here shows OAPM activity, and every one of those circles up there is a metroplex. OAPM stands for Optimization Airspace Procedures in the Metroplex. So the FAA is collaborating with operators in the metroplex to find better departures, better arrival procedures that deconflict with airports that underlie the metroplex area by using performance-based navigation. This activity is going to be a great benefit to all those who operate in those activities and help increase throughput. Right now, best capable, best served procedures are in operation in Chicago, Atlanta, and New York airspace when the weather conditions become such that the operations need to have this performance-based capability. So, you wonder about the budget woes, if that's going to affect NextGen. Well, NextGen is a multi-year, long-range program, and yes, there could be cutbacks in some of the near-term projects, but overall, this is a well-funded project, and it will continue. And some of the cutbacks that might happen here in this country won't affect how NextGen is being implemented all across the globe. So if you follow the money, NextGen is real and it's here to stay. Speaking about across the globe, I use the term NextGen, and what I'm talking about is the transformation of the air traffic management system. It's all being modernized. If you look at the sister organization of the FAA, you can see that NextGen technology is going into place into Canada. It's also going into place, of course, across the North Atlantic tracts. It's over in Europe and in the Far East and in Australia. So these technologies are being implemented today, and we use the term NextGen when we're talking about all of them. If you look at this timeline right here, these are the international mandates and the milestones for data communications, automatic dependent surveillance, and for TCAS 7.1. And you'll notice the one that's all the way to the right, that's actually the only milestone up there for the United States. That's the mandate for ADS-B out for all aircraft by 2020. So yes, the phone is ringing here at Cessna because our customers are asking us about things like RNP and RF legs, and the Chinese have recently asked about that on their new aircraft, and European customers are wondering about, do I need Link 2000? We have permanent exemptions that we're asking for all of our aircraft, but they might still want that technology. Precise RNAV or PRNAV, is a requirement in some airspaces in Europe, and TCAS is also a requirement. In Australia, ADS-B out is mandated for all aircraft operating above flight level 290 in December of this year. And in the North Atlantic tracks, again, FANS technology, data communications, I'll talk more about in just a minute. It's required to operate in the center track, and by 2015, all of the North Atlantic tracks are going to require FANS technology. So the ATM equipped beach mandates are worldwide. So now I'd like to talk a little bit more specifically about the technologies that are going to be needed in the cockpit. The communication, navigation, and surveillance, we just call that the CNS technologies. So first off, I want to look at this chart up here, if you will. The vertical lines are dividing up the timeline into 5-year increments. We're looking at block 0, block 1, block 2, and all the way to the right is block 3. 15 years out, the goal of all of this technology is to get to that 4-dimensional trajectory-based operations. Currently, we're in block 1. Looking horizontally, we're talking about the avionics, the communications, the navigation, and the surveillance technologies. What's important to note is that, again, we're in block 0, and this is both the ground side and the air side. These technologies have to have a roadmap to block 1 technologies and to block 2. So the avionics solutions will need to have an upgrade path to both of these blocks. Getting into the concept again of data communications. The benefits of data communications are going to be tremendous. All the way from the time an aircraft calls for its clearance, instead of using voice communications, they'll be able to get their clearance automatically uploaded to their FMS. As they taxi out and they get ready for takeoff, if there's a change in the runway departure or the routing, instead of having to call clearance delivery and copy down a new routing, that will be pushed to the aircraft, and the aircraft or the pilot will be able to confirm that that's a good route and automatically upload that. Once airborne, data communication has more benefits. Automatic check-in, as you pass through the different sectors, the controlling agency will just automatically be in charge of that, and there won't be voice communications required or the need for check-in. If there is a revision to the route because of adverse weather or traffic, that again will be pushed up to the aircraft. The aircraft will be able to display the new routing. The pilots will confirm if that's a good routing and then automatically upload that to the flight management computer. Again, not requiring voice communication. That's going to reduce a lot of errors that are already inherent in the voice communication system, like hear back, read back errors, or errors because of pilots stepping on each other when they're communicating. The other thing that can happen a lot of times is that when you're taking a clearance and you're writing it down and then you have to enter it in the FMS, you can make errors just in entry. Data communications eliminates that. So it increases a lot of safety. There's a lot of benefits with data communication, and it is the heart of collaborative air traffic management and on the path to 4-dimensional trajectory-based operations. Okay, the datacom systems in use today, there's really 2 technologies available. Link 2000, that's implemented in the European continent today, and FANS, which stands for Future Air Navigation System. That's for non-radar airspace. Let's talk about Link real quick. As you can see over in this map, this is the European continent, and in 2013, the areas in green have a requirement that aircraft that operate above flight level 290 need to have Link technology unless they have a permanent exemption. In 2015, Eastern Europe is going to pick up that. That is, the ground infrastructure is going to be enabled to accommodate airplanes that have Link technology. The brown airspace, well, that's still a political football. There are some countries that haven't been able to get the funding to get all that implemented, but that's not going to affect the aircraft. Still overflying these areas are going to have those capabilities. FANS, on the other hand, is technology that was invented decades ago by the airlines to communicate with their aircraft that are over non-radar airspace or out over the water. But it's a very good technology, it's a good platform, and the FAA is going to make it the cornerstone of its data communication program. Starting in 2016, the FAA is going to allow aircraft that have FANS capability to receive clearances and revised clearances while they're on the ground. Once the airplane is airborne, like I said, in the en route sector by 2019, they'll be able to upload new trajectories. FANS and Link 2000 are technologies that are available today, but both of those will be going away as the ATN-B2, or it's the NextGen communication system, comes online. ATN-B2 standards are being completed in 2013, and it's going to start the trial and testing phase. It could come online as early as 2018 and maybe more likely by the beginning of the next decade. So fans in Link 2000 are going away and they're going to be replaced by AT and B2. Okay, let's talk about the N in CNS, and that's navigation. More specifically, let's talk about performance-based navigation. This is where it really benefits the operator. For example, in the OPDs, Optimized Profile Descents, when an aircraft determines its top of descent, its ideal top of descent point, it will be able to begin an idle descent from high altitude all the way down to landing. This reduces noise. This reduces carbon emissions. Obviously, it reduces fuel. OPD procedures are coming into effect in the national airspace in the U.S. A lot of the real major benefits come from precision navigation. If you look at this outer line of spaghetti, this is how aircraft have been controlled for arrival and landing in the past. This is radar vectors. As you can see, it's not very precise. Go one layer in and you can see how GPS navigation allowed a lot more definition. However, because of aircraft differences, those turn radiuses were all a little bit different and unique to the aircraft. But with the advent of RNP, or Required Navigation Performance Technology, with radius to fixed turns, you can see that this inner circle here is a very precise, and that is a ground track. The capabilities are tremendous for developing airspace in mountainous terrain and in high density airspace around metroplexes to help deconflict from other airports, buildings, etc. So RNP technology is coming into the national airspace. And then if you look at the very center, this is a tailored arrival. This will benefit the operator personally as they come in for an arrival with this type of capability, and traffic permitting, they'll be able to fly right to the runway based upon their best performance. So performance-based navigation will reduce flight time, it reduces track miles, obviously it reduces fuel usage, and overall saves in operational cost. The concept of surveillance or active surveillance, the S in CNS. Well, ADS-B is what really enables all this to happen, because we're transitioning from passive surveillance or radar, or the secondary surveillance like mode A and mode C, to active dependent, to where the aircraft is broadcasting its position derived from a GPS position. So ATC can see exactly where you are, and the real benefit comes from other aircraft being able to see other ADS-B out targets, or if the technology is called ADS-B in. That opens the door for even more capabilities, because when an aircraft can precisely see where another aircraft is, then it can merge to get behind that aircraft, or it can pass that aircraft. And that type of capability is going to be called flight interval management. It's going to take a little bit more cockpit avionics flight deck capability, but flight interval management will allow an airplane to follow another airplane based upon a distance or a specific time interval. ADS-B in is the pathway to forward-dimensional trajectory-based operation, and really where the operational benefits begin. But that's just the beginning. As I talked about, those are the enabling technologies in Block 0. We're moving over to Block 1, Block 2, where even more capabilities are going to be available. Flight interval management, I mentioned, in-trail procedures, surface indication and alerting will increase safety upon airport operations. Closely spaced parallel operations will increase throughput at busy airports. In the low visibility arenas, SVS and EVS operations are coming online. All those are Block 2 type of avionics, and so as we move from Block 0, that's just the starting point, we have to have a pathway to four-dimensional trajectory-based operations. So just to sum up everything here, NextGen is the technology that's going to make air travel more predictable, flexible, and efficient. It also is going to set us on a pathway to 4D TBO in the early part of the 21st century. This is going to enable our customers to fly where they want to go, when they want to go, and how they want to go. Over the next 5 to 15 years, there's going to be a continuous update and improvement in the ground infrastructure, and also a corresponding increase in new aircraft capabilities. So the Cessna team, we're very active here. We're working to evaluate the most viable technical solutions to meet our customers' needs. So I hope today's briefing has given you a good overview about what NextGen is. If you'd like to have more information, I recommend that you go to the FAA's website, faa.gov/NextGen, to learn more about NextGen. I hope you've enjoyed today's briefing. Thanks for watching. Good day.